How you doing? This is Mr. Anderson, and we're going to review some simplifying square roots and cube roots and doing those operations with those. So we've got 9 walkthrough questions that we are going to go through here. All right, so simplify the following radical expression given that our variable is greater than 0. So we've got a positive number. We don't have to worry about that. And make sure we're using radicals in our answer. We're not writing decimals. Okay, the way we're going to go about this throughout these walkthroughs is the square roots. All right, we're just going to look for pairs underneath the square root, because a pair underneath a square root, say you got square root of 3 times 3, right? That is just 3. Right? The square root of x times x is x, right? It's just one of those factors. We're just going to look for pairs on the square roots underneath the radical, and then cube roots. Right? We got a cube root of 3 times 3 times 3. All right, that we look for triples, right? That's just 3. Cube root of 3 times 3 times 3, or the cube root of x times x times x, right? That's just x. So we're going to simply look for pairs underneath the square root, and we'll look for 3 of a kinds underneath the cube root. And we'll make it nice and simple, not be thinking about really the perfect cubes or the perfect squares to be taking out in this walkthrough. Okay, so I want to start with, I've got to simplify this. I'm going to start with a factor tree, and I'm just going to break this 180 down until I cannot break it down anymore. The prime factorization. Okay, prime factorization. So 180 is 18 times 10. Let's break 18. 9 times 2. Let's keep going. 3 times 3. Right, that's a prime number. That's a prime number. That's a prime number. My factor tree is stopping at those points, so I'm circling those points so I don't forget. And 10 is 5 times 2. Both prime numbers. I'll circle those. Okay, I am ready to rewrite what I'm going to be simplifying. Now, do not forget you already have something on the outside of the square root. It stays on the outside of the square root. Don't go throwing it inside the square root or something like that. So we've got 3y cubed. And then inside the square root, instead of writing 180, right, I'm going to write what is the same as 180. I'm going to write all these factors right here. So I've got 3 times 3 times, I like to put my numbers that are matching right next to each other. So 3 times 3 times 2 times 2 times 5. All right, that is the same as 180. And this x to the 5, right, I'm going to write that down as 5 x's multiplied together. And then I've got, 6 y's? That's the 6 of the y's multiplied together. 3, 4, 5, 6. Okay. Let's make this square root just a little bit longer. Now I'm going to go through and I'm going to circle all the pairs. Right, this is a square root, so there's a pair of 3s. Here's a pair of 2s. I've only got 1 5. Here's a pair of x's. Another pair of x's. Here's a pair of y's. Another pair of y's, and a third pair of y's. Okay, don't forget that you have this already on the outside. You're 3y cubed, or you could say 3 times y times y times y. All right, and then each one of these circles, because we are just looking for pairs, right? Each one of these circles here, those are all coming outside your square root. Those are all coming outside the square root as just one of those two factors, like square root of 3 times 3. That is just 3. Square root of 2 times 2. That is 2. The square root of x times x. That is x. All right, I have 2 of those. And then we got square root of y times y, which is y. And I got, what, 3 pairs of those? And then what do I have left over that I couldn't take out of the square root? And there's a 5 there. And I have this x over here. Right? Those are still stuck underneath the square root. And let's remultiply all of this back together to clean this up a bit and simplify it. Okay, I've got 3 times 3 times 2. That's 9 times 2. That's 18. All right, and there's so many factors here, you may want to like cross them off as you go along. Okay, I want to put my letters in alphabetical order, so I'm going to put my x's first. I have one x there and another x. X times x is x squared. All right, and then I have my y's. I've got 1, 2, 3 y's multiplied together right there. 4, 5, 6. I got a total of 6 y's multiplied together. And then I got square root of 5x. There is my simplified answer right there. Let's take a look at this with a cubed root. Exact same thing with a cube root, only you will see that we are circling 3 of a kind instead of 2 of a kind. All right, so let's do our factor tree. Break it down until it does not break down any further. Okay, so 54 is the same thing as 3 times 3, notice 9, times 3 times 2. You got your 9 times your 6, and I broke it down. As far as it go to the prime factorization, I am ready to write down what I'm going to be simplifying. Don't forget, when you have stuff already outside the square root or cube root, in this case, I have a 5x squared. That's already on the outside. Please don't forget that. Okay, and then don't forget also that this is a cube root. Write that index of 3 every time that you are simplifying, so that you don't forget from the beginning of the question to the end of the question, this is in fact a cube root. Okay, instead of 54, I am going to be writing 3 times 3 times 3 times 2. And then I've got 3 x's there. So I've got times x times x times x. And then I have 5 y's. So 1, 2, 3, 4, 5. Okay, and this is the key. I am going to go through and I am going to circle 3 of a kinds, right? I have a cubed root. The index is 3, so I am circling 3 of a kinds. I got 3 x's there. I have 3 y's. So the 2 doesn't have any matches. That's going to be left under the radical. I only have 2 y's over here, right? I can't make 3 out of that, so those are stuck under the cube root still. All right, let's simplify. Don't forget, this is already on the outside of the cube root, so that's there, 5x squared. Here's something that comes out, times 3. And here's something that comes out, times x. And here's something that comes out, times y, right? Just like with your square roots, right? You're circling 3 of a kinds now, and each one of those only comes out as one of those factors. The cube root of 3 times 3 times 3 is 3. It comes outside the cube root. And what do I have left over inside the cube root? I have, I've got this 2 here. Couldn't take that out. And I've got a pair of y's over there. So I have 2, and then y times y is y squared. Okay, let's re-multiply what's outside the cubed root. And I didn't write my cube in there. That's a cubed root. Let's re-multiply what is outside the cube root. We have 5 times 3 is 15. And then the x's, let me cross these off as I go along. 5 times 3 is 15. And then the x's, I have 1, 2, 3 x's. So that's x cubed. And then I just have the 1 y here. And so I'll just write that down. All right. And don't forget, this is a cubed root. And be real careful on the placement of your cube. Make sure that it is like readily identifiable as a cube root, because notice what you could do if it was over, if it was like over here, right? Now that's y cubed and you have a square root. So you got to be really pay really close attention as to where you put those numbers. And left inside the cubed root was 2y squared. Here's my answer. Done. Let's take a look at number 3. Divide, assume all variables are positive. Okay, so we have a square root divided by another square root. Our rules of radicals tell us we can just put this under 1 square root. All right, so this is really saying this right here, 72 x to the 10 divided by 6x cubed. Okay, and writing it like that, I can more readily see what I can be simplifying here. I can simplify these numbers right here, 72 divided by 6, which is going to be 12. And I can simplify all these x's right here. So let's do that. Okay. This is going to give me the square. 72 divided by 6 is 12. And then I have x to the 10 over x to the 3 is going to give me x to the 7. I like to think of it, and just doing a quick sidebar here, I've got 10 x's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in the numerator, and I've got 3 in the denominator. I like to think of it that, hey, I've got 7 more x's in the numerator than I do the denominator. I think, hey, 3 of these x's are going to cancel out with 3 of those in the numerator, leaving me with only 7 x's. Okay, because I've got 3 in the denominator, and they are canceling out with 3 that are in the numerator, leaving me with 7 x's, right? Multiplied together, x to the 7. You might remember from your exponent rules, right? If you are dividing same bases, then you subtract the exponents, 10 minus 3. Okay? I think of it more in terms of visualization. I have these 3 x's are going to cancel out with 3 of those x's and leave me with 7. That's the way that I think of it. Or there's 7 more x's in the numerator than the denominator. All right, let's simplify this. Factor tree on my 12, that's 4 times 3. 4 is 2 times 2. Those are all prime factors. That's where I'm stopping. So I have here 2 times 2 times 3. Oh, I've got a lot of x's here. I got 7 x's. 1, 2, 3, 4, 5, 6, 7. And let's circle. Okay, looking for pairs. Whoops. Looking for pairs. That's what I'm circling. There's a pair of 2s, pair of X's, another pair of X's, another pair of X's. And so each of those pairs is coming out as one of those factors. I have square root of 2 times 2 is 2. And I've got 3 X's coming out. Each one of those comes out as a single X. And then left under the square root is a 3 and an X that were not circled. Simplify that a little bit. I've got 2x cubed square root of 3x. And that's my answer. Let's look at, what are we up to? 4. Okay, so question number 4 is actually the exact same as question number 2, where we simplified a cubed root. All right, because here we are multiplying cube root and cube root. I can write that underneath 1 cubed root, which is what I'm going to do. All right, when I write this, and I'm going to break it down to absolutely as small as I can go, but this is what it's going to look like. I'm just going to put all the factors underneath 1 cubed root. Okay, so let's do our factor trees. 9 is 3 times 3. And 2025, no problem, because I think of it as $20.25, and I think, okay, how many quarters is that? There are 40 quarters in $10, so that makes 80 quarters in $20. And then I have one more extra quarter, so that's 81 quarters makes $20.25. So that's the way I think of it anyway. And let's keep breaking that down. 9, that's 9, that's 5 times 5. Stop in here because those are prime factors. Each one of those 9s is 3 times 3. And I'll stop at the 3 because that can't be broken down anymore. Those are prime factors. So I am ready to write this all under 1 cube root. I've got 1, 2, 3, 4, 5, 6 of the 3s. 3 times 3 times 3 times 3 times 3 times 3. And then I've got 2 of the 5s times 5 times 5. And then I have 4 x's multiplied together here. And I got another 4 x's multiplied together right here, which gives me a total of 8 x's. So I got 1, 2, 3, 4, 5, 6, 7, 8. And let's go through and circle, right? This is a cubed root, so that means I got to circle 3 of a kinds. There's 3. Another 3 of 3. I only have 2 5s, can't circle that. And there's 3 x's. There's another 3 x's. And then I'm left with 2 more x's that I can't circle. Each one of those circles comes out as only one of those factors, right? So there's a 3 here. There's another 3. Then I've got an x and another x. Right? Each one of those circles comes out as just one of those 3 factors. Left under the square root is 5 times 5, which is 25. And I've got 2 of the x's for x squared. Let's recombine, not combine, but multiply that. And I have 9x squared times, oh, I didn't write my cubed root in there. Okay. Cube root of 25x squared. And there's my answer, okay? Same thing as just simplifying 1 cubed root, okay? Because I can write both of those cubed roots underneath. When you're multiplying, you can just put that all underneath 1 cubed root, okay? All right, let's take a look at our next one. Question number 5. Okay, expressed in simplest radical form, given x is greater than 0. Okay, the way this question was set up, there should be, it's missing a, 3x square root of 5x. All right, it's just restating the question down here. And I was missing the 3x square root of 5x. Okay, which might be kind of confusing. I could just as well erase all that. But the blank is where I'm putting my final answer. Okay, so this is combining like terms, right? And like we know 3x plus 7x. I can do that, right? Those are like terms. 3x plus 7x, of course, is 10x. Or I could say 3x squared plus 5x minus 2x squared, right? I know that I can combine the x squareds, right? Those are like terms because they have the same variable with the same exponents. I can combine those to give me just one of the x squareds, but I can't combine that 5x with anything. It's not the same as anything else, right? So it's the same with this, only I have radicals as well. The radicals have to match up. They have to be the exact same index with the same radicand on the inside of that. So let's look at what we have. Here I've got a x square root 5x. Do I have any of the others of those? And yes, I do. X square root 5x. So I've got 2 of those. Let's see what else I might have. Do I have any other square roots of x? Yep, here's one over here. And notice that this right here, square root, I don't have any other just plain old square roots of 5. They have to match. The only thing it doesn't have to match is these coefficients. All right, these things out here, these don't have to match. Right? Right? It's just like telling you how many of those you have. Like I've got over here, I've got 3 of the x's. I'm adding 7 more of the x's, and it's giving me a total of 10 of the x's. All right? It's just telling me how many of those x's do I have, right? And the same thing here. Those coefficients don't have to match up. Make sure that you are, when you're combining, you're taking it with the sign in front of it, right? So I have, I'm combining this one right here and this one right here. Make sure you're taking it with that sign in front of it. So I have 3 of the x square roots of 5x minus 1 of the x square root of 5x is going to give me 3 minus 1 is 2. So I'm left with 2 of the x square root of 5x's. Okay, I got 2 of those. 3 minus 1 gives me 2. I got those taken care of. Bump. And then let's see, I can combine the square roots of x's. So I have negative 7 of those square roots of x's, and I'm adding 4 of the square roots of x's, all right, to give me a total of negative 3 of those square root of x's, all right, right here. Okay, so I got those taken care of. The only thing I have left, I cannot combine. I've got plus 4 square roots of 5. There, I've combined all of the like terms that I can combine here. Okay, I end up with just 3 terms. Remember that terms are things that are added and subtract. Terms are separated by pluses and minuses. You add and subtract terms. All right, there's my solution. Moving on. So in the next one, when we first look at it, okay, oh yeah, these are not like terms. I can't combine these. There's nothing to simplify here, right? You're looking at this right here. You're like, okay, the letters need to be the same with the same exponents, and your square roots have to be the same with the same radicands. I can't combine these. But the thing is that you have to, they're not in simplest form. You've got to put them in simplest form first. So simplify first. Let me write that right. Simplify first. All right, then you can see if you can combine these because they're like terms. Okay, so I got to simplify. Let's do our factor tree. That's 15 times 10. That would make 5 times 3 and 5 times 2. This one over here would be 9 times 6, which is 3 times 3, and 3 times 2. I'll circle all those prime factors so I don't forget one. All right, so what do I actually have here? I've got x squared square root of 5 times 5, got those two taken care of, times 3 times 2, and then I still have an x underneath there. Okay, how about the other one? Minus, I've got a 9x on the outside, and then my square root, I've got 3 of the 3's. 3 times 3 times 3 times 2. And then I've got 3 x's. All right, and this is just, I'm simplifying each one of these terms separately to see if I can combine those. All right, let's circle our pairs. We got a pair of 5's here, and that's all I can take outside the square root there. Here's a pair of 3's. Here's a pair of x's. Those can come outside the square root. So the term on the left side, right, that's coming outside the square root. That's 5. I already have x squared outside the square root. All right, that's that right there. And then left inside the square root, I have 6x. Okay, let's take a look at the next one. Let's see, I've got a 3 that's coming outside and an x. All right, so that's going to give me the 9, and the 3 is going to give me 27. All right, this is coming out as 3. This is already out as a 9, so that's 9 times 3 is a 27. Here I have one x already outside. Here's another x coming to the outside, gives me x squared. And what do I have left under the square root is 3 times 2 is 6. And I have an x left over. Look what we have, right? We have x squared, square roots of 6x, x squared, square roots of 6x. Right, I've got 5 of those minus 27 of those is going to give me a grand total of negative 22. 5 minus 27 gives me negative 22 of these x squared square roots of 6x. Negative 22 of those things there, and that's my final answer right there. Okay, so I had to simplify first in order to see that I could actually combine like terms here. question number 7. I'm going to rationalize a denominator here. We all know we can't have a square root, any sort of radical in the denominator. That would be terrible. That would be just terrible if we had a square root, cube root, something like that in a denominator. We got to get rid of that thing. So I could simplify that square root first and see what I actually need to take out, or I could do it at the end, simplifying. So we're just going to do it this way. We are going to multiply the denominator and the numerator by the square root of 40. And this takes care of the whole issue. All right, because we have here, we've got a pair, right? We got a pair of square roots of 40. Square root of 40 times square root of 40 is just going to give me 40. All right, that's going to come outside the square root. I think I'll do a sidebar here. This is 40 times 40. I've got a pair of 40s, which comes outside the square root as 40. All right, so that gets rid of the square root in the denominator. I have, in the numerator, I got 5 times the square root of 40. Now, that can be simplified yet in the numerator. I could simplify the 5 and the 40 already, but let's see if we have more that we can simplify. All right, so doing a factor tree on a 40, let's just do it right over here. That would be 8 times 5, or you could say 4 times 10. There we got 4 times 2 and 2 times 2. I'm going to circle all these prime factors that I stopped at. So this would be 5 times 40 is the same thing as saying 2 times 2 times 2 times 5. This is over 40. Let's circle our pairs. I have a pair of 2's, and that's it. So the 2 is going to come outside the square root, right, as just one of those. I'll go ahead and write that. 5 times 2, and then left inside the square root is 10 over 40. 5 times 2 is 10. Square roots of 10 over 40. And I just have this number yet here that I can simplify, right? 10 over 40. The numerator and the denominator can both be divided by 10. I can divide that by 10, and I can divide this by 10 to give me 10 divided by 10 is just 1, right? And I don't need to write that 1 there. It's understood that I have 1 square root of 10 there. 40 divided by 10 is 4. And there's my simplified answer. Okay. Notice in this that this was the key right there, right? Multiplying by that denominator over that denominator. It gave me a 40 in the denominator. No more square root, right? So that was the whole key. The rest of it was... all the rest of this stuff is, just simplification. Okay, but actually rationalizing the denominator, all right, that happened very early, and the rest of it was just simplification. Okay, rationalize another denominator here, and we've just got some letters in here now. So we're going to do the same thing. It's a square root. We're going to multiply the denominator and the numerator by the same thing. Anything over itself is just 1. So we're going to multiply by square root of 8x cubed. All right, because that gives us a pair of 8x cubes underneath the square root, which is going to come out as just one of those pairs. So in the denominator, I have 8x cubed. And in the numerator, I have a 6x squared already outside the square root, and then inside the square root, you could do a factor tree on the 8 if you wanted. 4 and 2, that's 2 and 2. Right? 8 is 2 times 2 times 2. So I'll write 2 times 2 times 2, and I got 3 x's. Let's circle our pairs. That gives me 6x squared. I've got a 2 coming outside and an x coming outside. So times 2 times x. What's left inside is a 2 and an x that was not circled over 8x cubed. Two times 6 is 12. And then we've got 1, 2, 3 x's for x cubed. And then square root of 2x. And we've got over 8x cubed. 12 over 8, that can be simplified because I can divide both of those by 4. Divide that by 4, divide that by 4, and that's going to give me 3 over 2. X cubes, right? Those are just going to cancel out. Right? X cubed over x cubed. Anything over itself is just 1, so those cancel out. And all I have left now is 2x in the numerator. There's my final answer. 3 square roots of 2x over 2. Nice. And we got one last question here. We are multiplying binomial radicals. Multiplying binomial radicals. This is double distribution, or FOIL, as some of you kids might like to call it. Okay, I've got to distribute that 4. And after I distribute the 4, then I got to distribute that other term of negative square root 75x. Let's see how this goes. You know what? It'll make it easier if I simplify that square root of 75x first. Let's do that. Okay. Square root of 75x. That's 25 times 3, 5 times 5. Okay, so square root of 5 times 5 times 3 times x. That is a square root of 75x. Right, and this is the only thing coming outside the square root. And left inside the square root is a 3x. Okay, so I'm going to rewrite this thing as 4 minus 5 square roots of 3x times 6 minus square root of 3x. Okay, now I'm going to start distributing. All right. I'm going to distribute that 4 with both terms in the other binomial. So 4 times 6 is 24. All right, doing that part right there. 4 times 6 is 24. And then 4 times negative square root of 3x is just going to give me negative 4 square roots of 3x. Okay, I've distributed that 4. Now it is time for me to distribute that negative 5 square roots of 3x. So negative 5 square roots of 3x times 6 is going to give me negative 30 square roots of 3x. And then I've got to multiply these last two here. Negative 5. I'm just going to write this one out, and we'll simplify it in the next one. So I've got negative 5 square roots of 3x times negative 3, whoops, negative square root of 3x. There we go. Okay. Let's simplify some stuff here. I see I have like terms right here, right? I've got square root of 3x squared. I got negative 4 of the square roots of 3x minus another 30 of the square roots of 3x. So that is going to give me 24. And negative 4 minus another 3 is going to give me negative 34 of those square roots of 3x. All right, and I kind of left this multiplied out here. And that was because, notice I have a square root of 3x times another square root of 3x, right? That's a pair. That's just going to give me a pair comes out as just one of those. That's going to be just 3x. I got a pair of 3x's under a square root. It comes out as just 3x, right? And then I've got like the negative 5 here, and that negative is going to give me a positive 5. So let's write that out. I got positive 5 times 3x. And it doesn't match the other stuff, so I'm really just ready to write my final answer. I would typically put this right there. I'd put that in the front, 15x, and then I'd write my square roots of 3x, and then I'd write my number. Yeah, I'll go ahead and do that. 15x, that's that right there, and then minus 34 square roots of 3x, that's that right there, and plus 24. That's that right there. And there's my simplified answer. Okay, and I think that's all we got here on our review. So that is our simplifying square roots and cube roots by circling pairs with our square roots and circling 3 of a kinds with our cube roots. And well, we kind of stuck to that with the simplification. A lot of simplification here. Just keep in mind throughout this, we just circled pairs and we circled 3 of a kinds when we ended up with a cube root. And there was only, 2 cube roots that we had. Here we multiplied a couple cube roots, and there in question 2, we simplified. Okay, well, that's our review, and I will see you in class.